All right, here's our movie on our proof multiple choice questions. You will have a few of these on your quiz tomorrow. So number 1 says if BD bisects angle ABC. So angle ABC is getting bisected. So when we cut or bisect an angle, we get two congruent angles at the vertex. So we can swoosh off angle ABD and angle DBC. And we have that BD is perpendicular to AC. So BD being perpendicular to AC makes right angles. It says then triangle ABD can be proved congruent to triangle CBD by which of the following? For free, we can put on, as I call, our math goggles and see that BD is being shared amongst the triangles. And if we follow this, we have more angles than sides. So travel from one angle to the other, we pass by the marked off side. So it is angle, side, angle, choice B. Number 2 says if C is the midpoint of AD, so if C is the midpoint of AD, then from there, we would get AC congruent to CD, and then BCA is congruent to, angle BCA is congruent to angle ECD. We would be able to mark those off. It says which of the following can be used to prove the two triangles congruent by side angle side. So for side angle side, if we took this triangle, I highlighted the angle that we have. In order for it to be side angle side, we need to go side, then that connecting angle, and then the other side that's part of that angle. So that would be BC, and the corresponding side that would be marked off in the other triangle would be CE. So the answer is choice D. BC and CE would have to be congruent. Number 3, a lot of you had trouble in class on number 3. It says if AB and CD bisect each other, so they are cutting each other into two equal pieces. So AB is cutting CD into two equal pieces, and CD is also likewise cutting AB into two equal pieces. So we get that marking off. And since we have two intersecting lines, we get the vertical angles just by looking at the picture. Which of the following can be used to prove the triangle is congruent? If we take any triangle, it would be side angle side. Again here, side angle connecting to the other side. This goes in side angle side order. So the answer is choice B, side angle side. Number 4, if AB is perpendicular to BC, we would get a right angle at the vertex B. If AD is perpendicular to DC, we would get a right angle at vertex D. And BC is congruent to DC. It says which of the following can be used to prove the two triangles congruent? Well, we get one more thing for free. It's the reflexive property on AC. So right now, if you were to try to spell this out, a lot of you are getting this confused. A lot of you think this is side angle side. But if I took the top triangle and tried to connect the two sides, the angle in between them is not marked off. So it doesn't spell SAS. It spells ASS, which is no good. So we can't use that. We can't use side angle side. That's no good. So what we have to do is think of something else. These happen to be right triangles. So HL is eligible. Remember, HL stands for hypotenuse leg. If we take a look, the hypotenuses of both triangles are marked off. That's the shared side, AC. And then this is a leg, that's a leg. Hypotenuse leg works. Choice D. If you have right angles and you have SSA or ASS, it's going to be HL, as long as you have right triangles. If you don't, then you don't have a hypotenuse, you don't have a leg, you can't use HL. All right, number 5. It says if AB is congruent to BC, which of the following cannot be used to prove the triangle is congruent by side, side, side? So we're being asked, we need to use side, side, side. So let's see, AB congruent to BC, that's our given. We get the reflexive property for free, and this is what we want. In order to do side, 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 we would need AD marked off with DC. So if we take a look at choice 1, BD bisects AC, that would give us the markings that we need for side, side, side. But the question says cannot be used to prove. So that would not be the answer. That actually gives us side, side, side. Next statement is AC is the knife cutting BD into two equal pieces. Well, that's not even true. That's our actual answer. But let's just go through the rest of these. If D were to be the midpoint of AC, then you would make these dashes. You would mark those sides congruent. That's what we would want for side, so that's not right. And BD being a median would mean D is a midpoint, and we would get those same marked off sides. So choice B is the answer. Number 6 says, if AB bisects DC, so again, AB is the knife. It is cutting DC at E, cutting DC into 2 equal pieces, which of the following may not be true. Well, DE has to be congruent to EC. Whoops, I'm sorry, that's not the answer. DE is congruent to EC because DC is getting bisected. Again, I use this analogy. Say, John cuts Jake's hair. Okay. AB bisects DC. Jake's hair is getting cut. DC is getting cut. That's why you have DE congruent to EC. That's true. We do not know that DC bisects AB. We don't know that, for example, we don't know that Jake cut John's hair, so we don't know that AE is congruent to EB. That's the answer. Let's talk about these other ones. Angle AED is congruent to angle CEB. AED is right here, CEB is there. Those are vertical angles. That's one of those things that we're allowed to get for free. We're allowed to look at the picture and say, oh, we have vertical angles. So that's definitely true. Then, last but not least, E is the midpoint of DC. Well, if DE is equal to EC, then E would have to be the midpoint of DC. So that's actually true. So the only one that may not be true is AE is congruent to EB. That may not be true. All right, number 7 says, if D is the midpoint of AC, if we know D were to be the midpoint of AC, then AD is congruent to DC. We get that? It says, which of the following statements will allow the triangles to be congruent by side angle side? So far what we have is we have AD and DC congruent, and we also get the reflexive property for free. So if you think about this, we want side angle side. So what that means is we really need this included angle, side block side. We need this included angle to be marked off. Okay? We need the included angle to be marked off, and if you notice, it looks like a right angle. That's what we want. Now we have to see which given would do it for us. Part A says BD bisects angle ABC. So for part A, BD bisects an angle ABC, all the action would be occurring up here. That's not what we want. We want the action to be occurring down at D. So that's no good. That's not the answer. And I'm actually going to erase that writing, because that's no good. We don't want that. Part B says BD is perpendicular to AC. Well, that would give us the right angles that we wanted. That works. C says BD bisects AC. Well, if BD is bisecting line segment AC, you get the equal part. Whoops, sorry. You get the equal parts again, but we already knew that. We would get AD congruent to DC. We already knew that. That's not going to give us anything new. AD congruent to DC isn't going to give us anything new either. Choice B is the answer. Number 8, if triangle ABC is congruent to triangle CDA by side angle side, and we know BC is congruent to AD, it says which of the following angles must be congruent? Well, we get the reflexive for free. And again, if we want side angle side, this is so critical. If I pick the top triangle, side, blah, side, I need the angle marked that's connecting them. So if I look at the first choice, angle BAC, I don't need BAC marked, I need BCA marked. So that's gone. Okay. Choice B involves BCA. So here's my swoosh. This is choice B now. But it also involves DCA. So if we took a look at the lower triangle, here are my sides that are marked off. I don't need angle DCA, I need angle DAC. We need the angle that's included amongst your two sides. So I don't need angle DCA. I don't want that. So choice B is gone. We already said we need angle BCA. So we need angle BCA. Choice C doesn't involve that angle at all. And now choice D says angle BCA, check it, that's the one that we wanted, is congruent to angle DAC. That's the choice that we want, choice D. Next one, if says if BD is the perpendicular bisector of AC, then how are the triangles congruent? Two math words. Perpendicular, that means BD and AC are going to meet at right angles. And bisector, that means BD is going to cut AC into two equal pieces. So just from perpendicular bisector, this is how we can mark off our paper. And as always, we get the reflexive for free. So if we take a look, side, then the angle that's in the middle, and then side. Side angle, side is the answer. Number 10 says, if AD is congruent to CB, here we are, what other information is necessary to be given in order to prove the triangle is congruent? All right, so I'm going to go through these one by one. AE congruent to EB would give us this. And then for free, we can always keep the vertical angles involved. But here's the problem. If we take a look, if we went around the triangle, it would be angle, then the side, then the side. It would not be side, angle, side. Side, angle, side would require, for example, that A would be marked off. But right now we have SSA or ASS. No good. So this gives us SSA, not the answer. So we're going to get rid of that. I'll just remark this with the givens. So the blue can stay. EB congruent to EC. EB congruent to EC would not work because there's nothing going on in the other triangle. We need information in both. We need a pair of sides congruent in both triangles. So that would not work. Next choice, angle DAE, swoosh it up, is congruent to angle ADE. Oh, double swoosh, really. That doesn't work either because that's in the same triangle. Doesn't work. And so one more, angle DAE, swoosh, double swoosh, congruent to angle CBE, double swoosh. These triangles would be congruent by angle, angle, side. So that does work. Choice 4 is correct. All right, number 11. If AB is congruent to BC, and BD is an altitude, since we have an altitude, remember, altitudes are going to create right angles. There's our altitude. Then the triangles are congruent. Let's see. Well, we get reflexive for free. So just from the marked picture, if you were to try to spell this out, we would have angle, then side, because the angle connecting the sides is not marked off. So you have SSA or ASS. That's no good, but we have right angles. So we have right triangles, so we're eligible for HL. Since we're eligible for HL, we have to check. So here's one triangle. The hypotenuse is marked off in green, and the leg is marked off in red. So HL would work. What's hard about this question is realizing there's another way to do this. If you see, I'm going to put that triangle aside for a moment. If you see, we have one big isosceles triangle. Triangle ABC is isosceles. So if we have the two sides marked off congruent, the angles opposite those sides are congruent. So the green gives you the green there. And so angle, angle, side would also work because of the isosceles triangle ABC, giving you the equal angles. What won't work in any configuration is side, angle, side, because I don't have, so for example, I don't have this angle, the angle at B, the angles at B marked off, or I don't have the sides downstairs at AD and DC marked off. So 2 and 3 only is correct. And then I asked you to complete page 4, so here we go. It says, if triangle ABC is isosceles, so we have isosceles triangle there. And then by that, we would also know that the base angles are equal. And we also can see reflexive property. So here's our picture. It says triangle ABD can be proved congruent to triangle CBD, which are the following. Well, right now, if we were to spell this out, we would have S, starting here, then S, then A. Because this angle is not connecting the two marked off sides. So SSA doesn't work. So right now, you would not, I shouldn't say the triangles are not congruent, but you can't prove them to be congruent at the moment. So choice D, Roman numeral 3, is the answer. few more questions here. If BD is perpendicular to AC, so that means we have right angles, then which of the following statements will allow the triangles to be congruent by angle, side, angle? We get reflexive for free. So if you follow this around, we have angle, side, and what angles would we need congruent? Well, we would need the angles at B, the little angles at B to be congruent. So let's see. BD bisects angle ABC. Since BD is cutting an angle, that would create two congruent angles. That would work. That would give us angle, side, angle. If D were to be the midpoint of AC, so in choice B here, if D were to be the midpoint of AC, it would give us those two sides, which would produce side, angle, side for us, not angle, side, angle. So that doesn't work. This would produce side, angle, side. Doesn't work. If BD bisected AC, you would still get two congruent sides producing side, angle, side again. And if AB was congruent to BC, so I'm going to get rid of the blue for a moment. If AB was congruent to BC, you would actually here have not ASA, but HL, the hypotenuse being AB and BC, and the leg being shared at BD. This would be HL. Or you can get more creative and see the isosceles triangle. That would give you angle, angle, side, but not angle, side, angle. So these three choices don't work. A is the only one that works. That's the answer. One more. This one seemed to elude people, so it's tricky. In the figure below, it said D is the midpoint of AC. So AD is congruent to DC. And then DC is congruent to EC. If I already have one slash on DC, and EC is congruent, so I'm only put one slash on there. So what happens is, so for example, if EC was 5, since EC and DC are equal, DC is 5. And since DC is equal to AD, because D is a midpoint, AD is also 5. So all those pieces end up being equal to each other. So which of the following is always true? BE is congruent to EC. Well, we know nothing about the size of BE. We don't know that E is a midpoint, AE is a median, anything like that. AD is congruent to BE. Again, we don't know what BE is, so we don't know that this is going to be true. It could be true, but we don't know that it's true. AD is congruent to EC. Well, AD in our example was 5. EC is 5. Plus, more importantly, they have one dash on each. That's going to work. AC is congruent to BC. Well, we don't know anything about BE. So we don't know, even though we know AC, like for example, in this case was 10, we don't know anything about BE, so we have no idea what BC is. So our only option that we know is true is choice C.